Hello all. Today we are discussing about direct memory access concept in computer architecture. So in this session we will learn what is DMA, why DMA, block diagram of DMA and how the data transfer between the input output devices to memory. So these are the four concepts will be covered in this record or video. So coming to the concept direct memory access. Why direct memory access? So up to now we are already know that okay, I want to transfer the data from the input output devices to memory. For that definitely I need the attention of CPU processor. Without CPU intervention I can't perform any data transferring. So the main motto of direct memory access is to perform the transformation of data from input output devices or peripheral devices to memory with less intervention or without intervention of the CPU as it is possible. Uh, this is the main motto, and why we are applying DMA controller is okay. For example, CPU initially executing some main program. Okay, at that time CPU if CPU can get any interrupt from the input output device, the input output device may want to transfer the data from devices to main memory. At that time what the CPU will do, CPU initially resume the current execution of the program and it has to pay the attention for the interruption. So if you observe that the CPU valuable time may be wasted, and coming to the data transfer rate of input output devices are very low. So the CPU has to spend lot of time for transmission of data. So to avoid this problem, to avoid the CPU consuming time, we are using the direct memory access. So in this direct memory access what will happen is initially here also the DMA controller accept the interrupts, nothing but accept the request from the input output devices. After that it will ask CPU to give, to retrieve, to grant some control lines to perform some task. So it will be clearly understandable. So coming to the block diagram of DMA, what will happen exactly? So before that, okay, I want to perform the data transmission. So definitely to perform data transmission, bus is needed. So bus is a, we have different types of buses, data bus, address bus, control bus, different types of buses are there, but the bus is needed to perform the data transferring from one component to another component. So definitely we want buses from the CPU. That is the main thing. Second one is definitely before retrieving the data, before retrieving the control lines from the CPU, first we have to ask CPU, please provide the bus for us. Okay, so okay, coming to the block diagram of DMA. So if you observe this diagram, the DMA controller consists of three registers: address register, word count register, control register. And if you observe that address bus buffers, data bus buffers, so these buffers are connected to the address bus and data bus. Okay, all components are connected to the internal bus. And coming to the control logic, if you observe that DMA select, register select, read, write, bus request, bus grant, interrupt. Okay, so definitely we will explain all those components one by one. Okay, for coming to the address register, what will happen? Okay, what is the main motto? I want to transfer the data from the input output devices to memory. So definitely I need the address location of that particular memory. Okay, I want address. Based on the address I can perform the transmission. So what the address register will do is it will store the initial address of that. Okay, once okay address is done, then word count register. For example, I am taking some characters through keyboard, so each and every character need some address. Okay, one character will be stored in one address location, another character will be stored in another address location. So what will happen? So how many words is nothing but there is a chance to storing the characters also. Here the register name is word count. Okay, number of words is going to be stored. Okay, what the word counter register will do? Okay, initially I want to perform, I want to transfer the four words from input output devices to memory. So initially what happened, the word count register initially consists of count is 4. Okay, after that one word is transferred to the memory. So initial after that it will be decremented. Why? Because the word is already transferred to the memory, so it will be decreased. It will be going to be 3, and then 2, 1, 0. So when the word count register shows that it consists of 0 value, okay, the DMA controller understands that yes, the transmission is done. And coming to address register, what will happen? I am already told you that address register consists of initial address of that memory. Okay, one word occupies some address location and second word occupies some other address location. What will happen? Address will be incremented and word count will be decremented. Hope it is clear. Next, control register. What the control register will do? The control register will manage all those things. And coming to the control logic, if you observe that what is DMA select and what is register select. Okay, initially what happened is, please carefully listen. Initially what happened is, the initially DMA controller will take the request from the input output device. Once it is accepted, it has to perform the transmission, right? So without CPU intervention, we can't perform. So what we have to do at that time? We have to we have to retrieve all the control lines for the transmission. We have to retrieve all the control lines from the CPU. Okay, at that time what it will do, that it will send some bus request to the CPU. Okay, once the CPU is verified, then it will send the bus grant. Okay, all the buses, all the required buses. What are the required buses? Address bus, data bus, okay, and read and write control lines. All the things are to be transferred to the DMA controller. Okay, once the control lines are retrieved, the CPU can perform their own tasks. Okay, the CPU is can't interrupt by these transformations. CPU can do those things, and DMA controller will perform the transmission. So if you observe that what happened here, the CPU time is saved. At the same time, the DMA will perform the transmission. Okay, okay. What the DMA select is, once the bus grant permission is received from the CPU, the DMA select will automatically enabled. And coming to register select, if you want to perform to transfer the data to the register, at that time the register select may be enabled. And okay, I want to perform transform. How it will be done? Okay, either it is reading or writing. Okay, read operation or write operation will be done. So that's why if you observe that it is a bidirectional. And BR is the bus request, bus grant, BC is a bus grant. And coming to interrupt, here we have a doubt. Is there any possibility to get the interrupt while performing transmission from input output devices to memory? Of course it is possible. Why? Because here only we are taking single example. Okay, single input output device send some request to the DMA controller. Yes, there is a chance, right? Multiple devices may send the request to the DMA. At that time what will happen? The DMA may be interrupted. Okay, at that time it sends some interrupt signal to the CPU. That is one possibility. And second one is, okay, CPU is executing some program. The CPU want to perform transmission. At that time what will happen? The CPU also be interrupted. At the same time the CPU need control lines to perform the transmission. At that time the CPU may send interrupt to the DMA controller. Okay, once it is received that interrupt from the CPU to DMA controller, immediately the operation what is done, it will be immediately stopped. So this is comes under interrupt. I hope all are covered. And data bus buffer and address bus buffers. So data bus buffer, it will stores the data in temporary manner, and address bus buffers also, it will stores the data in temporary manner. Next, coming to data transfer, how the data transfer will be done? If you observe this diagram, so initially the first one is CPU. The CPU, it consists of interrupt BGBR, and it consists of four control lines. What are those? Read, write, address bus, data bus. And coming to the random access memory, it can also consist of some control lines. Next, coming to the control logic, nothing but DMA controller. DMA controller also consists of the control lines, and here we are representing the some input output peripheral devices. So here we are using the four components here. So okay, let's see how the data will be transferred. We are already discussed initially. It from the it receives from the request from input output or peripheral devices. Okay, once the request is received, it will immediately send bus request to the CPU. Once it is granted, so the grant acknowledgement is sent back to the DMA controller. Okay, bus is also granted. Then what he has to do? The DMA select or register select may be enabled. Okay, so all those control signals are transformed to the random access memory. By using these four control lines, we have to perform the data transmission from input output devices to random access memory, nothing but memory location. So once all these transformation is done, the DMA controller will send some acknowledgement to the input output device. Okay, your transmission is successfully done. So this is about direct memory access. In future videos we will learn what is bus arbitration, like that. Thank you.